Okay, so this is an update of the transistor tester, which is, this is actually the transistor tester, but this is a jig or a case to a contactor. Basically, it's a contactor for the pins of the transistor, for the SMD transistor. And it took me like 2 days to make it. Yep, it was very hard. I've tried different permutations, different ways of making it. This is plastic, by the way. I melted it by hand with my iron, melting iron, soldering iron. As you can see, is not uniform, and it's a little bent here. I especially bent it. I purposely bent it to make a fit. And what this is having here, I hope you can see it. I can actually draw it for you. Let's take another piece of paper. What is having there is having like this 3 legs, metal band legs like this, and this is the plastic all around, and these legs are bent like this, and the second one, and the transistor is staying with the legs up, instead of staying with the legs down like normally you put it on a board. Here is with legs up, and these pins are pins, contactors are pressing on the pins of the transistor. So here is the transistor, and here is the pin. It's not perfect, but is but it's doing its job. Sometimes I get very messed up transistors, and I've already put one here, and sometimes it's working just by really they're making noises now. Sometimes is working directly when I'm fitting it. Let's test it. Let's see if it's yeah, you see, from one shot, so it's without pressing it. But sometimes the legs, you can see there, the legs are non-uniform, not on the same plane. So one leg is more up than the other, and those contactors are I really try to make them bendable, but they are pretty stiff. They are not that elastic or springy as I wished. They are a little bit if I'm pressing it hard. For some transistors, is a bit more difficult. When I take them out from the board, they have that uniformity on the legs, and I'm just showing you. I've already cataloged. You can see here. I hope you can see. I have a bunch of this. Is it? And that one, which you don't see it. Yeah, 6 bags, little bags of transistors, and let me order them. Let's see. NPN, PNP, PMOS, and NMOS. This is weird shit. BJT, NPN, I don't know what. I made this cataloging after the results from this transistor tester, SR tester. This is very weird transistor reading that is giving me this transistor tester is giving me this reading. I call it 3 to 1 and 2 to 1, or 1 to 2 and 1 to 3, or inverse 3 to 1 and 2 to 1. But yeah, actually that's the first one. But there are multiple ways, not only these ways that you see here. I don't know what they are, at least the reading that is giving me. I'm not sure what these are. If you know, please help me with it. Illuminate me. I have this guys for a while, and yeah. So let's test another one. As you can see, let's see. I hope you can see it. You can see the non-uniformity is having a little pad left, a little wider. You see, it's really not the same level and size of the legs, and it's super tiny, and it's very hard to work with them. To make the contact, the legs contact. That's the major issue that I was trying to achieve. Come on. Yeah, sometimes I'm very dexterous, and I'm putting them there without. I think this is a bit more fat than the others. I think it is a little bit different, tiny bit. Yeah, these markings that I put, one leg and two legs, the points are fantastic, helpful. Yeah, this one fit perfectly. I think there are. Do you see this one? This is way more smaller. This is medium. This is, I think, it's a bit more fat than the medium ones that I made here. Well, it's not for everything, I suppose, but for the most of them, like 90%. And this is perfectly catching on the pins, and that's exactly what I wanted. Let's see if it's working from the start without pressing it. Nope. I get a diode. That means only two connections are made, not all three. So I have to press it a little bit. Let's see if now it's doing the job. Yeah, you see, PNP. So I hope you can see it. You see it? PNP, PNP. So yeah. Sometimes is reading it, depends on the pins. Is reading it perfectly without pressing it, which is fantastically good. And this is my method of everything that you see here is I made it, and now he doesn't want to came out, really. Yeah. So again, I'm repeating myself. This is plastic melting. I call it 3D printing, manual 3D printing, without any kind of machine. Just with my hand and with my soldering iron, and this one the same. is this is a piece of cardboard that I made a square, and inside it I contained the plastic. These are different plastics, different categories of plastics. For the white one, I used PP or 005. This one, PP 05, polypropylene. And for the blue one, I used also propylene is called PE02, high density, HDPE is called usually, or PE. And these two plastics, PP, or 05 and 02, they don't stick each other. If I'm melting one plastic over the other, they just don't like each other, and they are naturally flying away very, very, very quickly. If I'm doing a little bit of, if I'm forcing it a little bit, it will jump out very, very quickly from the point of contact. And that's very good to know and to use, and it's exactly what I use here, this technique of non-melting plastics one with the other. Yeah, I've tested a lot of, I made a lot of tests until I reached this point. This is also not perfect. I wished to be a bit more better than this. And also you can see the wires are going to my first tester that I, well, not, this is not my first, but the previous tester that I made, which was 50-50. It was hard to put the transistor there, but you see right now how easy it is to put it and to take it out, and the contacts are back, you know. That's extremely good and exactly what I wanted. And sometimes it's giving me the reading directly, without pressing, it's just there. It's just contacting, making the contact perfectly. Sometimes, but some other times I have to jiggle to help the contact, this little contactor on the pin. You know, sometimes it's not fitting well, and probably the dimension and the form, shape of the pin is having more soldering on it, or you know, little deformities on the pins, too bent or something, and they are not making all the time 100% contact, but usually like 70% of the time, 65, 70, 75% of the time is contacting it perfectly, almost perfectly. And I wish to have this kind of tool, well, you know, industrial made, not homemade like I did it here. Yeah, it will be cool to have something like this, and probably in the future I will make a board for this, and not wired to that one, because this is in the testing mode. Another way of testing these transistors, instead of inserting them in this little jig, especially if they don't fit that hole, or some very weird problems they have, I can use them directly on this. I've tried it before and it worked very good, but now in this moment it doesn't really want to work at all. It doesn't want to stay here. Yeah, it's a bit problematic. te în pula mea să te fut în pizdă. Te în pizda, mătii de dracă, răpănos. Handicapatul, du-te. Hai în pizda, mătii, că ai mers adineauri să te fută în limbă. Yeah. Okay, that's it. So there. PMOS. So this is another way of testing. It's a bit problematic. PMOS. It's a bit problematic to fit it there, but it's another way of using it, and if you get very dexterous on it, with it, it's a good thing, especially for different transistor, different sizes transistors, and different weird pins with a lot of solder on them, like this one that I have here. I'm not sure if you can see. Let me bring the light. You see this pin is having a little bit of solder that I can take it out by force. But yeah, they are weird stuff like this. Pizda mati. Yeah, it got the reading. it got the reading. I think this is the one. So 2 to 1 and 1 to 3 direction of the diodes. I'm not sure what this kind of transistor means. If you know what it means, please tell me. Let's check if it's this guy, because it jumped. Yeah, exactly this one. Okay, excellent. So I get the same result, 2 to 1 and 1 to 3. This is how I'm naming them. So I have here, what are you? This little bag, 2 to 1 and 1 and 3 to 1 actually, 2 to 1 and 3 to 1. But yeah, they are not the same, but yeah, I don't know exactly what they mean. And I mean, what this tester it means for him. But yeah, that's another way of testing them. And this one is having a very bent leg, very weird configuration. I'm not sure if I can insert it and read it from here, but yeah, I hope you can see me how I'm working. Now it's very good pressed there, and by this easily inserted. Let's see if it's reading it from the start. Yeah, do you see? NMOS. So let's see, NMOS, NMOS. Okay, so this is, I'm taking it out. Bloop. And bag it, put it in the bag. Now another one. Let's choose another one which is having a bit more normal. Yeah, well, not everything is having normal pins. Are you the correct size here? Yeah, okay. Probably I got lucky. I put a very small transistor. Let's see, like this. And the contactors managed to, let's see if it's reading it from the start. It's giving me a diode when it's staying that long. Sometimes, yeah, that's the problem. Now I'm pressing it. Every time I'm doing this is getting me a false reading. I'm not sure why exactly, but if I'm using my other method, which is a bit more dexterous method, let's see it like this, and I hope it is making contacts. It's still giving me a diode, huh? Alright. Come on, baby. Nope. So this is probably blown. This is bad. But usually when I'm getting... No, it's good. NEMOS. A lot of times I'm getting this diode reading and after a couple of tryings I get the NMOS or PMOS transistor reading. So this is NMOS, and yeah, it's a bit, sometimes it's not reading it correctly, especially these two categories. Do I have time? NMOS and PMOS, these two categories, I'm getting a little bit more, it's harder to read them than here, but I managed to find a way. I thought those transistors were bad with the diode reading, but yeah, let's try another one. Hopefully it will be a PNP or NPN. Those are extraordinarily rapid. I get a reading, very rapid, very fast reading for the PNP and NPN transistors, and sometimes without pressing it, without forcing. Oh, another weird one, but it's good that I get it from one shot without pressing it, so the contacts are perfect right now. And is also the pins, it matters, the pins of the transistor. If it's brand new, is absolutely no problem, but these are transistors that I took them out from boards. Look. So this is the weird one, no? The diode bullshit, which I have no idea what they are. Here. I want to show you very quickly PNP, how quickly it is read. And I hope I will be fast enough. And voila. Huh? Come on. No. So let's see. I have to press it a little bit. And voila. PNP. I hope you can see everything here. Yeah? PNP here in the first row. So my Really? So my experiment, I'm really happy with this transistor contactor helper. Well, and whoop, what it was, PMP, yeah. And I wanted to show you how fast and easy I managed to develop this little rig or jig, and I'm very, yeah, it's way more faster, way more direct. Well, I like it. I like it. I like it a little bit. It's faster. I like it because it's faster. It's not terrible. It's not terrible precise. I get some misreadings because it's there are some problems with the transistors themselves, and also my contactors here are not as bendable as I wished. They are a bit more stiff than I really wanted them to be. I wished they were a bit more springy, and they are not that springy. Let's test this. So usually is working from the first try. Yeah, it's good. So this is 2 to 1 and 3 to 1, 2 to 1 and 3 to 1, and it's going to loop to the specific bag, this one. So well, I'm not sure if if I've already managed to sort, to read half of them. Probably I did. I'm not sure. I didn't manage to read half of them yet, but it's going way more quicker than like this, extremely quicker to read them, especially if I have a lot of them. It's way more quicker than any other ways, like that way, or see how without touching it is just the NPN and PNP are fantastically fast reading. I get without pressing, without it's little, you know, tricks. I think the program is doing something with the MOS, NMOS or PMOS. It doesn't really, you know, I'm not sure why it's not making the contact. I forget what this was. What this was. This was PMP, I suppose. Let's test it again. I was talking. I was thinking what to say, and yeah, it's reading very quickly. Yeah, voila, NPN. So where are you? The bag, NPN. Here. I just proved to you that is correct. That is true what I'm saying. How quickly is reading them. The NPN and PNP is very quickly and very easily. I'm not sure yet which is the problem, if it's my jig the problem or this tester is the problem for this ones, for PMOS or NMOS, which I have a lot already. NMOS. These ones I get only one diode reading a lot of times, and after one or two tryings I get the real NMOS reading from my tester here. I'm not sure what is the problem exactly. I think it's this guy, because for the NPN and PNPs I get a very fast reading. So it has to do with probably it's a mixture. It's a combination of of, I'm not sure, of wiring. Yeah, you see, I get a diode, and if I when I see that I get a diode, I know for sure it's a NMOS. Let's see if I'm pressing it. Maybe I'm getting. Nope. Let's press it in 2 points right now. I'm pressing in the middle first time, and now on 2 points. Okay, so no. I'm really unbelievable. I'm very sure the contacts are made. Yeah, it means this is damaged, or my guy there, my transistor reading doesn't recognize this one, so this one is probably burnt. But let's see another one, and how fast it will read it, because yeah, there are some problems sometimes. It's not perfect, but let's see. Yeah, you see, good reading and very fast PNP. This is sometimes I get some very strange transistors models like this one. It fucked my day. But the other ones, yeah, there are categories of good and bad, you know. And PNP, it was this one. PNP. So yeah, let's do another one. Yeah, I hope you can see the pads. Well, the legs, they are having some very wide pads on them. I hope you can see it. Let me check it actually. Yeah, you see now how big the like very big splash of solder. So let's try this guy. Not everybody is like this. Some are like this. Some guys are like this. Not everyone. Let's see. Actually, it should read it very fast if it's having those contacts. Let's press it right now. But no. Let's try it again. Come on, no. So it's probably in MOS like that. Yeah, you see how dexterous I got right now? Come on. Oh, bloody hell. Come on, read it. Yeah, probably it's fucked up. Okay, so you see me doing testing the transistor here and here. These two together, and only this one as well, by putting it directly on the contacts there. But you think I'm an idiot and I didn't tried that pad. I did try it, and let's see. With this specific transistor, I had a bunch of problems. It should be this model of transistor with a diode connected on the emitter to collector diode, not just a simple NPN, but with a diode. So or PNP, I'm not sure which one it was. I think it was the PNP one. It's the same, and I have the normal ones. This is the normal ones without that diode there. So these are a bit more special ones. I don't know them all. I have no idea how everything is working, and and of course I don't have power, and try it again. And I'm always getting this capacitor value, and sometimes the resistor value, and always, every time I'm reading it. Yeah, let's leave it like that without. Come on. I don't press it at all. I just leave it there. Yeah, see, either it doesn't know it, or I get that C value, the capacitor value. Yeah, C. You see the capacitor. Okay, so this is here on the pad. Let's see directly here. I think I got diode reading here inside my jig. Let me position it. Nope, it's too big. It's bigger than the hole that I have here. There, it's a specific hole, and I must balance it on these contactors here. Let's hope it will be quick. Let's hope it will be quick and with no problems, I wanted to say. But of course I'm pressing too hard. And the thing is sleeping. Aye. Yeah, let's try it inverse right now. Let's see. Come on, baby. Yeah, you see? BJT PNP, and it's exactly the one with the diode from collector to emitter, exactly like so it's a PNP, exactly in my drawing. And yeah, that's the thing of that's the beauty of this thing, is really making some very strong connections. I was thinking actually to implement that kind of pad somewhere here, like like an extension, if something is not good here, to quickly also with elasticity, like a spring, like, you know, to press it into those elastic or springy lamels. I'm thinking exactly like is here. Well, can you see everything that I? Shit. I hope it filmed everything, and these are disturbed here. But yes, this is the thing that I wanted to show you. There are some special little shits that they need very special attention and very special connections, very special connections they need to actually to read it, because they are good. Even if I put on them a lot of heat from the heat gun, and yeah, I hope they are not damaged. And that guy is actually showing the real value and not some damaged value. So, an update on the transistor tester. Here are the transistors left, and all I want to say is that this little device that I made is very, very good, in the sense that I put the transistor in the matrix, what is called this, a mold of something, the case to hold the transistor, and then the contactors. I made the contacts, press the button, read the transistor, taking out, put another one. So basically that's why it's very, 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 very good, because I basically put the transistor, test it, take it out, put another transistor, test it, take it out, take another one, test it, take it out, and so on and so on and so on, one after another. It was really industrial working, and I finished them in a couple of, I don't want to lie, it was a couple of minutes, because it wasn't a couple of minutes. But if they were all brand new from a package from eBay or something, or bought from a store, if they were brand new, they were like that, pack, you know, one after another and after another and after another. The problem, there are some little details, little problems that I encountered. So that's the part that took some time, took some more time than you know, to try different permutation. I actually used the pads as well, these little 3 pads here, which are very good, and also these pads here are quite a lot actually, because in the course of time, using it, I kind of get the idea what is going on and what the problems are. And there are some problems, especially with these transistors that you take out from the board. One of the problems is that on the pins remains a little bit of fiberglass layer. When I get it out with something, when I push them out from the board, it's stuck so well on the fiberglass that a little bit of the fiberglass is still remaining on the pin, especially on on the side. So I don't know, I should make an example here to make you understand better. So let's say this is the transistor, and these are the pins on one side, but this is the thickness of the transistor, and these are the pins on the bottom layer here, and underneath them here, where they are actually soldered, here they catch a little bit a very fine layer of fiberglass. I suppose it's fiberglass. It may be oxidation, probably, but it's definitely something on the pin itself that is behaving like an isolator instead of conductor, pure conductor. How did I get to this conclusion? By observation, and actually I scribble with my knife this part. I scribble it until I reach the actual metal that is shiny, and here it was like a very dim gray, very close to, you know, to an oxidation layer or something, an isolator layer. So that's the main problem from these guys, from the that I take them out from the board. And my method, I will use the example again, this example again. So my method of putting my transistors inside this mold here, this case, is exactly like this, with the oxidation strut layer here, and when the pins are catching it, are making contact, they are making contact fine. The pins, these pins are making the contactors are making the contact fine, excellent actually. I was amazed on clean and metal pins that I had, how fast it, without pressing, without doing anything. So for like 60% of the transistors were clean, but other 40% weren't clean. They had a little bent pin deformation, but also that's that layer of isolation. And this is the way I am putting the transistor here in the case, and the contactors are actually making contact with that isolation layer that is here, and is giving me that capacitor value, that diode value that is wrong. Now if I'm putting it here, it's exactly the same thing, because I'm putting it with this isolation layer, but normal, in the normal way. This is upside down that I'm putting it here. So but here, like this is normal, and I'm putting it there, it's the same thing. Now the better solution is to actually put the contactors here, not on the bottom where they are soldered, but on top, where it is having a little ball of soldering, and here you know, little ball, drop of solder. On those drops, those contacts to step into, and this way, when I'm putting it here like this, I also must take care of the pins not to be bent. If it's bent like this, it will fall down, like you see me struggling before. But now I get the idea. They must be straight pins, and they are staying very good on this contactors. And now with this method here, I'm actually making the contacts from underneath on those soldering balls or drops, and that's why I'm getting extraordinarily good readings with this method. But is balancing, the transistor is balancing there, and is and somewhere if I'm pressing too hard, it will drop from to the on the other side, and I lose the reading, and I have to start over again, and it's annoying. It's very annoying way of reading it like this, a bit harder. This is very quick, this is very easy, very fast, is extremely good way of doing. If the transistor if all the pads are clean and metal, with metal, if it's metal on metal basically, or not metal on this metal from the contactor on the isolator of the, yeah. So that's the major point that I discovered in time, and this is my final argument, or my final saying about my little device here. It's extremely good. I really like it, with a little bit more with a little bit of exceptions that you must take care if you are building something like this. Take from my experience and my observation actually, because that's like in medicine is a saying, diagnosing is half of the solution resolving. You resolve the disease by 50% if you diagnose it correctly. So that's the thing that I'm doing here. I'm getting the idea straight, right now, and with this informations and this experiments that I did here, I can design another better one, hopefully, little device like this. What another point is that I've upgraded a little bit. I put a little bit of wire here to actually to hold this thing with 2 fingers. It should be more longer, you know, but it's good enough. It's like this. Come on. Yeah, I have to read that thing. So like this. Yeah, that transistor remained there. So this is the. You see. Let's make an. And also I've melted the plastic over the wire, and I made this port, the output port, with 2 wires here, and the third one that is getting out from the same side of the device. And let's see if it's good enough, I hope. And nope. Yeah, this let's press it. This is another method, by pressing it a little bit. Yep, it's good. It's good. So sometimes there are some imperfections, but the most important and the most dramatic problem was the layer of isolation that I had to figure it out, well, with a lot of experimentation, and that's I think that I covered everything here. Also, this little thing, I get a lot of these guys with a sign of a diode, exactly like in some cases I get only one diode reading or capacitor reading by not reading a pin. But here in this case, the device is reading all the pins actually of the transistor, and is giving me 2 to 1 and 3 to 1, or 1 to 2, or and 1 to 3 diode sense. And I think the device, my device, this tester, transistor tester, doesn't know what type of transistor it is, and is giving me a general idea what he interpret what he is measuring there, and is telling me, yeah, I find some diodes kind of like diodes, junctions or something, but I don't know what type of transistor is. I get the same reading. I'm telling you this, I'm specifying this thing because I find one single guy to whom I get a lot of readings like this, like diodes like this. But after more testing, and actually I tested there on the pads, I get that is a NJFET like this, and I got this kind of readings a lot of time, and in fact it was actually a type that he managed to find it after all. Okay, another point this time is the type of the transistors that I get the reading from this SR transistor tester, SR tester. Are these two categories, this category and this category. I smartly named them as PMP, but actually this guy is giving me the same name, BJT PNP and BJT NPN, for both categories, but the icon is different. The icon of the transistor is the normal one. I'm not sure how well can you see it, but it's the normal icon transistor, that you can see. Let me actually, like this, you see this guy. It's here a little bit and not that clear, but this one, I hope you can see it good enough. Or this one actually, let me focus it. Okay, excellent. And NPN, and this one is again, so this is the normal one, but this one is the normal one but with a diode from emitter to collector, and that's the difference on the icons, on the type of the transistor. And I think this diode is actually a protective diode for electrostatic voltage, over voltage, that can damage the junction inside the transistor, which is a bit weird. It should be that diode, it should be from the base to collector, pointing from the base towards the emitter, towards the collector, because the damage from electrostatic voltage or currents, well, the current is very low but the voltage is very high in electrostatic. It will damage the, first of all, the base of the transistor, but who knows, they know better. But it's my take and my opinion, actually, my interpretation of what that guy is reading and making the difference between this category and this category. And these guys, they also have a diode from source to drain and from drain to source, pointing from drain to source, and this one is from source to drain, is NA, and this is PA, and it's the same. That diode, I think, is for protection. I should read some data sheets about this particular diode element, but I wanted to point out that these categories are actually the same category, but this category I think is more protected, is with more protection than this one. But basically it's the same shit. It's exactly the same shit. But these ones are having that diode that is for more protection from electrostatic voltages, basically. If you touch it with your hand and your hand rub the piece of wool, you know, or and you have that sparks in your fingers, yeah, you can fuck it up very quickly. So yeah, that's it, and thank you very much. Oh yeah, it wasn't clear. Now it is. Thank you very much. Alright, another method of testing the transistors, especially more weirder ones or more accessible, I don't know, than my little gadget here that I made, is with this little jumper, and it's a bit tricky because you have to move fast, but I get the reading. These are the last, I didn't test them at all, and yeah, it's very, it's good, it's fast enough, but you also have to move fast and hit the pin with this jumper, and it's a bit tricky, you see. Yeah, well, but it's a bit tricky, but it's having some dirt. Yeah, now it's good, but can I? All right. So yeah, it's another method, and the point is that I'm using all the methods I can, and to read to finish all my transistors readings, basically. So it's what I'm trying to say is good to have multiple testing probes and ways, multiple testing ways. If something is not working in one, it will work in another. In first, in second, and third method, just have multiple ways of testing it, and it's what I'm saying. All right, thank you.